Hey guys, let's start with factorizing quadratics. Now, we've begun a new topic, quadratics. If you're not familiar with it, quadratics are similarly a different way or different form of graphing or different type of solving when it comes to a comparison with linear equations. So let me start off with its equation, its pure and original equation. And this follows with ax squared plus bx plus c. Now, we want to perfect this equation in order for us to apply this in all scenarios of solving quadratic equations. Now, today we'll be doing factorizing quadratics. Now, the meaning of factorizing quadratics is simplifying it into two brackets that have values of x, and we also have to also solve the values of x, so the roots of the graph, but we'll sooner learn this in our next lesson. So factorizing quadratics, let me just start with a basic example here. So as we know that we had ax squared plus bx plus c. Let's match it down. So a should come before x, so that's 1 here. B, so that's 5 here. And c is 6 here. So a, b, and c. A is 1, b is 5, and c is 6. Now let's factorize it. Let's make it into bracket forms. So now there's a technique, a method here. So with the value of c here, so we have 6. We are given a task to find out two values that add up to get a result of b and that multiply to get a product of c. So in this case, 3 and 2. Now I'll tell you why we choose 3 and 2. If we do 3 times 2, we get 6. And if we do 3 plus 2, we get positive 5. And that is how it's supposed to work. We multiply to get the value of c, and we add to get the value of b. We have to make sure this is sturdy in our mind in order for us to do this onwards. Now, since we have two values, 3 and 2 here, we can just simply put it into the brackets now. So we have x plus 3 and x plus 2. And that's simply how we do it. And we can just test it out if it works. So for us to expand brackets, what we simply do is we have to multiply it in this form. So x into x, and then x into 2, and then 3 into x, and then 3 into 2. So this would result us with x squared plus 2x plus 3x plus 6. And simplify this comes as x squared plus 5x and plus 6. And that is exactly how we have our first original formula. Now, with these values of x plus 3 and x plus 2 is equal to 0, I forgot to add 0, apologies here. So we have x plus 3 and x plus 2 is equal to 0. And now if they have given us a question saying that we have to solve values of x, then what we do here is let's create two equations with these given scenarios, x plus 3 and x plus 2, and make sure you equate them to 0 since it's a quadratic for a graph. So for the first one, x becomes -3, and for this one, x becomes -2. So in the coordinate plane, this would become the x value. So that would be -3, 0, and -2, 0. So these would be your two roots. And these roots lie upon the x coordinate. But if you don't understand this, no issues, because we'll be covering this up very soon. Let me go for another example. So let's look at the main concepts here. So we know that the product has to equal to c, and the addition of these two numbers has to equal to b. Now let's look at x squared. Let's see. Okay. X squared plus 6x plus 9. This looks very familiar if you look at multiple terms. Now let's start. Let's name our A, B, and C. So here A is 1, B is 6, and C is 9. Now as I said, the product of two numbers for C has to equal to C, and the addition of these two numbers has to equal to B. Now we have 9 here. What two numbers multiply to get 9 and add up to get 6? So let's try. Let's see if you can do 1 and 9. 1 times 9 is 9, but 1 plus 9 is not 6, so that is wrong. Let's try a different thing. Let's try different numbers. Let's try 3 and 3. 3 times 3 is 9, and 3 plus 3 is 6. Alright, now we found our simple brackets now. We've factorized it so easily now. X plus 3 and x plus 3. Because 3 times 3 is 9 and 3 plus 3 is 6. So we get x plus 3 times x plus 3. And that's how the formula goes, by the way. So since you have these two numbers, it's easily eligible for us to create these brackets directly. So now we have x plus 3 multiplied by x plus 3. Or you can also write this as x plus 3 whole squared, as they both are the same expressions given that I multiply together. So let's open up the brackets to see if it's right. So from x to x, x to 3, 3 to x, and 3 to 3. So x squared. So if you expand it, you get x squared plus 6x plus 3 times 3 is 9. And that is our original equation. Now this is clarified and it works. But now let's find out the values of x, or the roots. So we have x plus 3 and x plus 3, and always equated to 0 at all times. So two of these values become x is equal to negative 3 and x is equal to negative 3. So they are the same position or the same coordinate.